I'm going to share the screen. Hi, Internet. Hi, everyone. Hi, everyone who's here. Let us begin. So you're a developer learning Python. And this is the talk I wish I had when I started to learn Python. And actually, I think I had the best learning experiences of anyone because I had amazing teachers. Most people just have to figure all this stuff out in the first year or two of just going around and getting around the block. So we're going to have tons of things. We'll talk about it soon. Before that, so my name is Abu Salaf. Usually I'm a CTO consultant. I consult to startups on serious and difficult tech and tech organization issues. For fun, I run a programming dojo. Until today, it was always in Hebrew, but we'll see how this goes and maybe start doing English talks too. And it's just a thing I've been doing for fun since COVID started. Feel free to talk to me at this email address with any extremely hard problems your company might have, either technical or organizational, sales, whatever. And who are you? You are experienced non-Python developers. Actually, if you're Python developers, that's fine too, because we're going to mention way more than the syntax and probably you'll have something to learn. But what you shouldn't be is just starting to learn programming. If you're just starting to learn programming, honestly, this talk is going to sound like complete gibberish, and that's too bad. So just, spend a month or two learning the basics, come back to me. It will still sound way too advanced, but at least it will be helpful at that point. And so here's what we're going to talk about. We're going to talk about why to use Python, how to use Python, a bunch of gotchas, some best practices, some libraries you should know about because everybody else does and loves them, some tools we'll use, and a bit of internals that you might find useful just writing regular code. And we're going to do all of this very fast. The idea is definitely not to teach you Python. It's to give you an overview of what there is to learn so you can go about teaching yourself Python alone later. Let me just check that one very important guest is here with us. Yes, he is. He's my new intern. This talk is made in honor of him because he's a Java programmer learning Python for the first time, and he needs a talk like this, and one doesn't exist. So, hi, Guy. And so let's talk about why Python. The reasons to use Python are because it's so fast to develop in. It's extremely slow to run, like it's an order of magnitude slower than JavaScript, not to speak of C. But who cares about that, right? The really expensive thing is developer productivity. And Python is amazing at developer productivity. It's also very concise. It's very often that you see 5 lines of Python that would have been 100 lines of Java or C#. And it reads like pseudocode. Like, look at this code. This just tells you what the developer meant to do. Most likely he meant to do this with like 200 lines of Java, right? Here we have a single line that gets some data from the internet and parses it in one line. And then we have some code that uses a hash map to on sorted words to find anagrams and find the biggest anagram. This is amazing for like 12 lines of code, right? Some other reasons to use Python are Python does not get in your way. Like, if you don't care too much about your language and you just want to program, Python will not get in your way. It has a very pragmatic and sane ecosystem. Many people love languages for like having very passionate user bases. Python does not have a passionate user base. Few people love Python. I don't love Python. I think Python is horrible. It's just the least worst environment we have. like democracy. Every time I want to switch to writing code in another language, I get burned by how terrible that is. And Python just has a pragmatic ecosystem that tries to do things more or less right without being too pedantic about it, that cares more about delivering code than about things being too beautiful, but also does care about, not breaking production. So we don't have, for example, JavaScript's rush to replace the language completely every 6 months, which means we can focus on just writing code. And Python has libraries for absolutely everything. Like, it's very rare that I choose a weird domain to do a hobby project in and I don't have a library somebody uploaded that more or less works to help me do that. Specifically for some things, Python has the best libraries. Python has the best libraries for like research-oriented usage of programming languages where you're exploring things and need to look at the results immediately every time. So, math research, machine learning, scientific computing. Arguably, Python also has the best web backend libraries. There is a crowd of JavaScript developers not agreeing with me in the audience, and I cannot imagine what makes you think that. But this is my opinion. This is not like nobody would argue that some language has better machine learning libraries than Python, but many people would about the web backends. And now let's start a very fast tour of the language. So we saw this code already, but now we can click it. Oh no, seriously? This is horrible. All my examples are not going to work. We're going to have to waste time, which is the only thing we don't have here, on doing this manually. So this is Python Tutor. It's an amazing, amazing website. It can do this. What? Oh, I got the wrong version of the code. Sorry. This is going to take a minute. Should I change the talk because of the weird Bitly thing, like the service not available error? Yeah, we still have that. I'm going to have to just improvise. Way to start this talk. Okay, so we have words should be a list of some words. So let's say hello, oh hell, oh hi, hi-yo, yoo-hoo. And let's split that. Instead, like this just doesn't support getting things from the internet. And also we want a short example we can follow with our eyes. So we just created a dictionary. This is the most amazing thing, a dictionary. Oh my God, dictionaries are so amazing. You may know them as hash maps or just maps or hashes or JavaScript objects, more or less. So dictionaries are a magical data structure to replace all magical data structures. And if there's one secret ingredient to Python's being so concise and so amazing, it's dictionaries everywhere. So learn to use dictionaries. Seriously, if I spend 45 minutes out of this 1.5 hour long talk just telling you how amazing dictionaries are, you would start thinking like a Python programmer. Use dictionaries all the time. We just created an empty dictionary, and now we're gonna iterate over the words. The words are a list. We don't need anything like, indexes and to index into the list of words. We just iterate over the words. Any container you can iterate over. 10 years ago, that was a controversial statement. Today, even C++ does this. So for word in words, we're gonna take the word. Our word is hello, and we're gonna sort it and put that in a tuple. So now we have the sorted characters of the word. Note that word is a string, and sorting a string just gives me the characters because iterating over a string gives me single character strings in a row. Also note that there's a sorted function. It just does what you want. Amazing. So we have this hello key, and now we're gonna look in the dictionary. If we don't have that key, we're gonna initialize it to an empty list. So now we have an empty list here. And then we append the word to the empty list. And we're gonna do this again for OHL, which has the same key. So we're gonna append another item to this list. And let's do it again and again and again. And these have different keys, so they're gonna live in a different list. And now we can find the maximal length of a value in our dictionary. And we'll just run one like on each list and calculate their lengths and find the maximum of that. 1, 1, 1, all right. 0, and our count is 2. So now for every value, if the length is at least 2, which for our value, ANA, which is hello OHL, it is 2. So we're printing that. And for all the others, it's going to be less than 2, so we won't print them. That's it. That was a real Python program running. And as I said, concise, looks like English, very nice. Of course, nothing's perfect, but I kind of like it. Also, note this tool when you're learning Python. Use it all day, use it all night. It's amazing for like debugging your understanding of the language, for understanding what's really going on in the code. Okay, we have that, and we can keep playing the code. Now, this is the part where I'm supposed to show you a bunch of stuff about the language. Let's keep all that. We'll come back to it in the end real quick, if we have time, because you guys are programmers, right? You can Google all of this. You can do a project and figure it out. There's no reason to spend all our time talking about how the language works. Let's go to the interesting stuff. So starting with comparisons with other languages. I'm not going to compare to C because it's more different than C than it is with Java and in the same ways. So Python is a lot less bureaucratic than Java and C#. It's optionally typed, which means you're allowed to say what types your variables have, and then there is tooling to statically check that and catch errors that way, but you don't have to do it. If you're writing just a bit of code, if you're programming alone, much faster not to. It's very permissive in what it lets you do. Privates, for example, are not really enforced. They're just a naming convention everybody uses. There's very few places in the language where it actually does something special with private variables or methods. It's not compiled, it's an interpreted language. Actually, it's compiled to bytecode, and then that bytecode is interpreted by a virtual machine, but a lot less optimized, which nobody cares about, because if you need to do something fast with Python, you just write like a C++ extension to do that, or a Rust extension, or whatever. I hear those are all the rage recently. And you keep like your inner code that needs to be fast in a fast language, and all the wrapper code where you care about developer productivity, right, in Python, and everyone's happy. That's how it became, the language of choice for machine learning, the field famous for using all the words GPUs and CPUs for heat generation or whatever it is they do. Like in Java, everything is an object, but you care about it a lot less because you can just write functions. You don't have to write each object in its own, each class in its own file, and like Python is a lot more concise. We'll see that in many ways. other differences from Java C#, like what will you see done differently? Python, as I said, has dictionaries everywhere, and that means it's very easy to do quick and dirty things in Python, and they're okay. They look good, they're readable, they're maintainable. You can just do the quick and dirty thing and it works. So how is Python different than JavaScript? Basically, there's a lot less whats. I hope you all know that, right? What? I'm going to do a weird thing and reference another talk. If you guys haven't seen this amazing 5-minute talk by Gary Bernhardt, best tech talk giver in the world, then watch it in your free time. JavaScript is full of weird legacy things, like really weird legacy things. Python had 2 or 3, like very few legacy things. And we got rid of them a few years ago when we moved to Python 3, which was a breaking change. Python 2 code does not run anymore. And so you know, we don't have the whole double equals versus triple equals. We don't have dictionaries only using strings as keys. We don't have the weird weak typing stuff, like, you know, you can compare an int to a string and it will do something completely unreasonable. Actually, in Python, it will throw an exception like you'd want it to. Of course, you can't add an int to a string and it won't create Batman or whatever. So basically, I would say Python is like JavaScript designed by a sane individual. And I'm not saying anything bad about Brendan Eich, you know, he's wonderful. He had a weekend to do it. And then we got stuck with that. And yeah. So one more thing I wanted to say about Python and Java, not enforcing types means you can have a mixed list or a mixed tuple very easily. And those just save so much on like thinking time. I don't know, you'll understand it as you write some code and gain some experience. So a few things that will happen to you at least once, and they will be super weird and you'll crack your head on them. And I'm trying to make the debugging experiences faster. First thing is you'll get some tabs in your code and they'll be invisible and they will break it. Just beware of that. Never use tabs, always spaces. Python, by the way, has significant white space, which means instead of having 2 ways in our code to encode the concept of blocks, we have just 1 way, the indentation. That is a very nice thing about Python. So we don't have plus plus. Plus plus just doesn't exist. Just use plus equals 1. Same for minus minus. This is a list. This is a tuple. They are very similar, except the tuple is immutable. Python programmers easily get used to thinking of them as essentially the same and interchangeable, and we keep expecting them to be the same thing, except they really aren't. And Python doesn't consider them equal. So you might have a bug where some items in a collection are lists and other tuples, and you're trying to compare them, and the tuples are always different from the list with same content. Beware of that. Floats and ints do compare equal. Like 1.0 compares equal to 1. Keep that in mind. This is a joke. This is from JavaScript. It's not really a Python thing. At some point in your life, you'll try to modify a list while you're iterating over it. Don't do that. You can't do that. If you really need to, you will do this instead. You will copy the list using the list constructor. And now you can iterate over the original items and still modify the list in place. Or you'll use an index I to iterate over the list and do things with it. So this is a very interesting example. Let me actually visualize that for you. In Python, you can multiply a list. For example, A's is A 5 times, and that's fine, you know. A's. But you can't do the same thing twice, and I'll show you why. Let's run this. And the first time works fine. There's a list. We set one item. It works. The second time, we have three items in this list, all referencing the same list item. This is not good, because when we'll change it for, wait, what? No, I'm sorry. The example is wrong. It should be like board 1, for example. And then when you change this, it changes in all of them, not what we wanted, right? So what we do instead is this space times 3, and we do that for each I in range 3. That's the like normal kind of iteration in like numeric iteration in Python. And then you have 3 different lists. And those are much easier to change. Yeah, back to running over a crazy amount of slides. So Python doesn't have many scopes. We don't even have a scope for loops. Let me demonstrate how terrible this can be. So we have a for loop for I in range 10, I don't know, and I want to create incrementers. So incrementers are going to be a list, and this will be a lambda that accepts a number and returns the number plus I. And then I'll print, you know. Oh, and probably we should add that to incrementers. And then I'll use the last incrementer, and I'll use it with 5. And I'm expecting to get 5 plus 9. So that's 14. And then let's try to use the second incrementer, which I expect to get 7 from. And let's see what happens. So we do all of this, and we get a bunch of lambdas. And then, whoop, function object is, oh, I used inc instead of incrementers, sorry. The hazards of live coding when you have so much code to run through. I really should have made this example in the file. List index out of range, it should be 9. Not thinking under pressure. All right, so we did all that. We have all these lambdas, and then we choose one of them. And we have n equals 5, and we add I to that. As you can see, I is 9, so that's fine, and we return 13. And then we take the second incrementer, and this second incrementer, it's, wait, we didn't take it yet? We did? Oh, that's just inc, sorry. We took the second incrementer, and it's still bound to I, which is still 9. Wait, what? Like, we built it here. Shouldn't it be bound to the I as it was here? So the answer, very sadly, is no. Python does not have enough scopes. It only starts a new scope like in a function, globally, and in a class. So these are like the 3 scopes. I equals 5, def f I equals 7, class C I equals 9, def method I equals 11. These are the only scopes, and like every, for.
And you have with context.
Sorry?
With
With
context.
does not start a scope, no. Not at all. So like if I add a for loop here for j, whatever, and in here I create a I equals 1 situation, that will be the same I from here. Like almost everything I do in Python does not start a new scope. So there's a weird solution for that. And it goes like this. Wait, we should go back to the original code. We're going to use the fact that the default variable of a function exists and is only set once.
Recording.
So we're going to have here I equals I. And this works. Why does it work? Because this default argument was bound to I as it was. And as long as nobody specifies a new value for I, which we could specify I equals 6 here. And it will do something else, but who cares? We have a like private variable, like parameter for this function that just copies this I. And that's the way to solve this very strange gotcha. Back to our slides. So say we have a list and we write A plus equals this list plus equals another list. This would change the list in place. A equals A plus the other list would copy the list. Like, Python sees A plus list, creates a copy of the list, and then assigns that to A. Is that clear? I guess it is. You're programmers, you know this sort of thing. Python really likes underscore underscore init underscore underscore. By the way, we call this dunder when you have like 2 underscores inside. It's short for double under, and the reason you need that is that Python really loves things to have double underscores on both sides. So Python really likes dunder init files. A directory with dunder init files is considered a module or a submodule. You can import from that, and Python will agree to import things from that. If you're not managing, if you're getting import errors and importing things that should be there, the first idea to try is to add a dunder init py to their directory and maybe the directory above them if needed to. You'll understand what it means. The other issue is the opposite. Sometimes we import something and we have a file with the same name in the same directory, and we get a weird, the import works just when we try to use math.sign, it fails with math module does not contain a sign function. And that is super weird because you get that in runtime. You don't have compile time in Python. You get that in runtime and you're super confused. So just check your directory to see if it contains a math.py file that overrides the standard library math module. So you should know that try except exception, the base exception is called exception. It doesn't catch all exception. There's a even higher class called exception base, and some exceptions inherit directly from exception base. Things like create system error, which means just quit, something really bad happened, or keyboard interrupt, the exception that happens when you press Control-C, intentionally don't inherit from exceptions, so try excepts usually won't catch them. If you really want to catch keyboard interrupt, try except keyboard interrupt will catch it. But it's extremely rare that you would want to, of course, not stop the program on keyboard interrupt or on sys.exit, the exit command. So this is intentional. The global interpreter lock is a famous thing in Python. Mistake in the 80s. The way Python supports threading is there's a global interpreter lock, and only one thread can run Python code at each given moment. Threads are still very useful for when you have I/O, like if you need to read from, 10 databases on the network and 10 files from disk and write to 10 HTTP clients, I don't know, then you can still have 30 threads, all of them sharing the CPU happily, because 99% of the time they're blocked on I/O and who cares. But if you need to actually run code, they will run in lockstep. Like just one of them will run it at each given moment. That's why we don't use threading usually to improve performance of non-IO bound code. That also means Python threading libraries suck. Like I encountered a simple bug in one of the synchronization primitives. That is a very bad experience to have, and one that doesn't exist in any other language I ever used, because nobody uses threading in Python because it sucks because of the global interpreter lock. We have async IO, you can use that, it's very well tested. We have a thing called multiprocessing, which is a library in the standard library that helps you use processes as if they were threads. Be very careful of globals when you're using it. It's not that simple, but at least it solves the CPU issue. Python 2 used to be a thing. It's not a thing anymore. It has a bit different syntax, and they're not mutually compatible. If you get really weird syntax errors, ask yourself, am I accidentally running on a Python 2 interpreter? One place where you may find yourself running on Python 2 is, sorry, wrong terminal, this is the right one, is in Mac. Mac comes with Python 2 by default. So you have to write Python 3 to get a real Python. Okay, let's continue. Best practices, what to do. So PEP 8 is this wonderful thing. Some of you younger people won't understand why, but PEPs are the Python extension proposals. They're like RFCs for Python. And PEP 8, one of the first PEPs, shows a coding standard for the language, which means all the libraries, all the code in the world, everyone uses the same naming conventions for variables, the same amount of white space, everything the same. This is amazing, and follow that. It just means nobody argues about how much white space to use. A common thing I'll see people who come from Java or C# do is like create container objects for every specific piece of data they want, and like, POJOs for all their structs, and like a ton of data structures that are just simple wrappers over dict or list or tuple or just a bunch of fields. No, it's Python. Use dict and list and functions, that the regular building blocks, as much as you can. Like once in a while, you'll want to have your class point that just has X and Y and no methods, but almost always it's okay to use a tuple of size 2. Dict and list will get you so far. Functions will get you so far. You don't need, the strategy pattern with a class that has a run method. No, just use a lambda. If you're coming from C# or Java, you're familiar with the string builder pattern. That's important in Python too, because strings are immutable. So like trying to plus equals a string again and again will take O of n squared performance, and that's not good. So the string builder pattern is you have a list of segments, and it's just a Python list, of course. We don't use a special string builder object. And then you just empty string dot join your X. The str is in case it were the segments were numbers, but if it's just just empty string dot join segments would work. Actually, probably I wanted to write this. Yeah. So empty string dot join your segments is the string builder object. It's very useful. So everything in Python is compared using double equals, except for the non-object, which idiomatically is compiled with the is identity, object identity operator. It's just a weird habit Python developers have. There's no real reason for it, but do it because everybody does it, and don't be surprised if you don't. There's a bunch of different timekeeping functionality in the standard library. Use the datetime library. Everybody uses it. It's part of the standard library. Just don't use import time, use import datetime. Try running this at some point. This is a very cute feature of Python. So import this, prints out the Zen of Python by this guy who wrote the Python sorting algorithm, which is the sorting algorithm used by all programming languages these days. So we trust him. He's smart. Beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. Complex is better than complicated. Read this whole thing at some point. It will teach you a lot of how to think like a Python programmer. Some libraries we love. So these are part of the standard library, and you'll see them in every project. I will not find a project that doesn't use like the OS library for file operations, the sys library for the environment variables, for some exception handling stuff, for honestly lots of things that should have just been built-ins that you can access without importing. The JSON library, which is a very useful module for parsing and writing out and serializing JSON to Python objects like dictionaries and lists, of course, and the CSV module. I'll see them like the three of these almost in every Python file I ever see, and this one in almost every project somewhere. They're all really good, use them a lot. These are things I'll probably see in like at least half of them in every large project. So you'll certainly use them in your career. Regular expressions. One thing to say about regular expressions require lots of string escaping. Like you don't want to be writing \d plus \t. You know, there's so many backslashes in regular expressions. And of course, you're gonna need to double escape if you want an actual backspace. So backslash, so that's terrible. So in Python, we have R strings, which don't need backslash escapes. There's no way to escape quotes with them because they don't need backslash escapes. So that's the only reason to not use them with regular expressions. Subprocess is for calling other processes and checking the results and reading, etc. It has so many options, learn them. SQLite is an embedded SQLite library in the standard library. Logging is what log4j does for Java, except without the terrible security issues. It's very simple and very useful. There's struct for parsing like C binary formats. There's C types for calling C code very easily. There's func tools and iter tools and context leave, which add some like language utilities. Requests is the most loved Python library. It's not part of the standard library, I want to say yet, for some reason, but like it's the best example of how to design, document, evangelize the Python library. It's amazing. It's great. We all love it. It's an HTTP client. It's really good. Get to know it, use it all the time. Beautiful Soup is a really nice library for parsing and walking and searching HTML. So if you ever write, you know, a scraper, which we all do every time we're looking to rent an apartment, use requests and Beautiful Soup. So PyTest is an amazing unit testing library. It's magical. It's just completely magical. Unitest.mock is part of the standard library. It's a very magical mocking library that makes it extremely transparent and simple to write mocks for your like other components you want to use that are heavy. If you want to write a web backend, so Flask is a very lightweight option. Most microservices in the world these days use it. Fast API is like a faster Flask that uses type annotations to auto-generate your APIs. It's very smart about that. It also gives you like TypeScript .d files for your APIs and you know, Swagger, everything you need to have very well typed APIs in like zero work. Very nice library. Django is like the full-featured web framework you'd use for actually writing like web applications that have some server-side HTML, and maybe they don't, but they have like an admin panel. Django has a very magical admin panel that you get basically for free if you tell it what you're. It's like, you know, it's Flask really well integrated with an ORM. So you get like HTML to generate forms for your data types. You get it for free, and HTML for your, and handlers on the backend, of course, for authentication, for the admin panel, for stuff like that. Django is great. It's very Ruby on Rails like, but in some ways it is even better. You have two major ORMs in Python. Some people love SQL Alchemy. I personally love Django ORM. Even when I'm not using Django, I import Django to the project just to use the ORM. And I've always been retroactively very happy about it, because a week later I realized actually I also want an admin panel. And then I just quickly wrote up an admin panel in Django. And like, I use this ORM for desktop software, like, you know, with Windows that shouldn't even be a web project. Just Django has an amazingly good ORM. And so in Python, we have the WSGI and ASCII standards for like communication between a Python web server and a Python web framework. So like, you can use everything with everything. You can have Flask inside Django or Django inside Flask, handling different routes very easily, and like any of the huge amount of web servers in Python can work with any of the frameworks, and that's very nice. You also have PEP 429 and 428, which define like the interface of a database wrapper library, or like SQL database wrapper library. So most ORMs will support all the major databases, and that's very nice. If you want to write command line tools, Click is the library to use. These days, there's this new thing called Typer, which wraps it, and it's supposed to be even nicer. I didn't try it. If you're doing anything scientific or numeric at all, you want to use NumPy. NumPy is like, it's basically MATLAB in Python, which means it's super fast. Like, you can use it to write numeric code that will be much faster than the like not too optimized C code, because it will spend like one instruction running a Python instruction and then a few seconds doing like millions of operations in very, very optimized C and Fortran. It's a wonderful library, use it always. SciPy has some like higher level numeric code. Matplotlib is the visualization library everyone uses, and they're all very well integrated. Pandas gives you data frames, like R data frames. If you have used R, it's basically like Excel tables for NumPy, and super useful, super nice, very good library. These are, I understand, the major machine learning libraries these days. I know nothing about it, so I'm going to say nothing about it. Let's talk about package management for a bit. So you have pip, which is the basic tool you use to install stuff. Let's pip install IPython, for example. It's downloading and installing IPython. That's very nice. Now I have IPython. I can use IPython, which is a better REPL. It gives me all these nice features like %paste, which would paste my clipboard as code. Anyway, that's actually, there is a thing I want to show you about IPython. Let's take, for example, A will be a list, and tab completion is nice. So we have a.append, and I want to know what a.append does. So we have the question mark. And if it's written in Python, like ref, for example, so red.compile is written in Python, and that means I have double. Oh yeah, I have double question mark, which shows me the code. Very, very nice feature of IPython. So that was installing a package, very simple. We usually have requirements.txt, which is a text file listing all the versions of things we want in our let's go to the dot and look at, for example, upandas. Another example. Warehouse is a very serious Python library. So we'll have this requirements.txt file listing, okay, subfiles, fine, with all of our requirements. And that's the, and you can run pip install -r requirements.txt. All this happens on PyPy, the Python package index, where you have all the libraries, versions of them, etc. Let's take a newer version of Python. It will have much better documentation, probably. I don't know. So those are words to know, pip and PyPy. Virtual env is how we keep away from dependency hells. For every project, we'll start its own virtual env, which is a virtual installation of Python that has like its own site packages directory. Site packages is where all these things are installed. So ls/ where is it? I think it's library Python. Yeah, that site packages. These are all the libraries I have installed. For example, we just installed IPython, right? Oh, but we did that with the default Python 2 pip. I should have written pip3 install IPython. And now we can see, we're supposed to see IPython right here. Maybe it's the wrong version of Python. They have more than one install. No, I don't know. Anyway, site packages is where all these installations live. And of course, you have Python path, which is an environment variable to put somewhere else instead or in addition to site packages. But it's important to know this. Virtual env just creates a different site packages for your project. And that way you can install different versions of everything in each project. Always, always, always use this. Poetry is a more NPM, like a more modern wrapper for pip and virtual env, which you have like a poetry ini file in like configuration file that has exact versions of like that has packages you want, and then it has a poetry lock file which locks specific versions, and it always creates a virtual env by itself, etc. So for new projects, usually use poetry, but learn how to use pip because everybody else will be using it. If you want to create packages yourself, setup.py is like the word to Google. Setup.py is the file that defines a package, and today there's this new thing called setup.cfg that can replace it more or less entirely. I should tell you about pip install -e, which is the same as pip install, except instead of actually copying the code here to site packages, it just adds a little file here, this PTH file. Let's look at this PTH file, virtual env wrapper for blah 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 py3.pth. Yes, I want to look at it. So this thing just tells Python where to find this library, and then like it still lives in the development folder, and Python can be affected by live changes while you're developing. So that's very nice. Some tools we all use. So IPython I told you about. Jupyter Lab is a way more advanced version that started as it's an IPython offshoot, but it's today a different thing. It looks like this, and this is what scientific programmers use to do research. They have all their visualizations living together with the research code. Very nice. Use it whenever you need to. So we usually use either VS Code for just writing code or PyCharm for fancy. I am not fancy. I hate fancy. I hate things like PyCharm that tell me what to do too exactly. I prefer the VS Code like open extension model where I can mix and match simple extensions that help me write better code. PostgreSQL is definitely the Pythonist database of choice. It should be everyone's database of choice, but JavaScripters like NoSQL databases for some reason. So learn about that. You're going to use it a lot. Black is a tool to format your code, and it has zero configuration. You cannot configure it. It will format your code the way the Black developers decided code should be formatted. And it has no degrees of freedom. So it won't keep any of your previous code formatting. This is amazing because it means the amount of fights in your team about code formatting will go down to zero. iSort will sort your imports, which is just, one less degree of freedom, one less thing to break, like to create merge conflicts without semantic changes in the program. So these tools are great. Use them in every large project. Pre-commit is this nice Python tool to install pre-commit hooks to Git, so you can make things like Black and iSort run on every commit and refuse to commit unless they work. So MyPy is the tool you usually use to check your types if you chose to use the optional typing. And people who use it tell me to always run it in --= strict mode. Otherwise, it's more or less useless. And you can ignore comments wherever you need. Tox is this cute tool to check if you're developing a library and not a simple project, and this library will need to run in many environments. Tox is this simple tool to configure how to run your tests under 5 different Python versions, 3 different operating systems, and just you write tox run, and it runs all of them, which is really nice. cprofile is the Python profiler. It's part of the standard library. Learn to use it. It's very simple. PyPy is a different Python implementation written in Python. It has a JIT, which means for certain types of code, it's much faster. Few people use it. Some companies saw that it's faster and decided to use it. I think not 100% of C extensions work with it. So not everyone uses it by default. A bit of internals. Let me just check the clock first. So this was an hour. We have half an hour left. A bit of internals. As I said, Python compiles your code to this bytecode that the Python virtual machine runs. This is CPython. This doesn't apply at all to PyPy. All of this section is CPython. So it saves them in a subdirectory called dunder pycache as pyc files. And that's a cache, so it only needs to recompile files that changed. and not recompile everything every time you load a Python program. Makes things much faster. Useful to know it exists. I had a weird bug once in my life where things behave differently the first time I ran code after a change than other times because it was creating the PyC file that time and somehow it affected something. Dunderdict, okay, Dunderdict, I'm gonna have to show you these things in a REPL. So Python 3, let's create a class, and we have an init method. Actually, let's not create anything. Let's just import re. We have these compile these regex objects. So let's say or some white space and then my last name. And let's call this R. So I have this object R, type red.pattern. Now this object has a dunderdict thing. This thing is, okay, wait, my mistake, I wanted r.dunderdict. No, patterns are C objects, not Python objects. So what do I have that is a Python object? I think, okay, let's look at CSV.reader. I want to read a.csv. So I have this CSV.reader object. And oh no, it's also a C object, so it doesn't have underneath. Fine, I give up. Let's create a class C, and it accepts X and Y and saves them. Self.x equals X, self.y equals Y. And now let's create a C object, and it needs, of course, X and Y. We have C.x, etc. Dunderdict is the dictionary internal to my object where these things are actually saved. And it goes both ways. I can, I can change it, etc., etc. And C, by the way, the big class also has a Dunderdict where it has this init function and some other stuff. So I can, access the init function method I defined using C's Dunderdict. I can also just write C dot. So it's useful to know there's just a dictionary for every object that contains this object's properties, except for classes that define this thing called slots. C objects now can't have an X. It's not allowed. They can only have a B, a C, or an A, only these things. And now they're stored in a list instead of a dict, and that's better for memory performance. So that's the only time you don't have Dunderdict. Globals is this magical thing that gives you all the globals as a dictionary. And again, it can be edited. Globals hello equals hi, and now we have a hello variable that equals hi. Locals is the same for local variables. It can be useful sometimes. A bit about importing. So you have this thing called sys.module, which is of course a dictionary. Everything is a dictionary. Let's look at its keys. So these are all the modules currently loaded to the system. If we try to import CSV, we'll just look for CSV in sys modules, find it, and return it to us. Sys.modules, CSV is just the CSV module. If it doesn't find it, it will call this thing called dunder import dunder, which actually imports it. Of course, this is Python, so we can write our own dunder import dunder and replace it. Syspath is where it searches for things, so for modules. So it's, you know, current directory, the site packages. Oh, yeah, we're using the site packages from opt homebrew lib Python 3.9. I was right, we do have more Python versions, and that's why we didn't find IPython where we looked. If we will look here, we will find IPython. IPython, found it. Right, so syspath is where we search for things. Of course, we can modify it in runtime if we need to look for modules in another place. We already talked about the existence of the global interpreter lock. So remember, it exists. It doesn't in PyPy, of course, different implementation, I think. Don't trust me, actually. Python's garbage collector is a reference counting garbage collector. So locals are released very, very fast at the end of functions, plus a generational garbage collector for longer living things. Hopefully this told you something, the seniors among you, very useful to know. You can import GC and, you know, optimize it, disable it temporarily, re-enable it, and even, I don't remember how to do this, but you can ask for all the objects, just all the objects. No. Oh, let's look at the first 100 objects. These are all the Python objects in this process. That is pretty amazing. So these are a bunch of things to Google some more internal relevant things, and let's run back to a language introduction because we have some time left, 25 whole minutes. So you already saw the read eval print loop. That's a thing Java and C# don't have. It's this, I just write Python and I can run some code and try some things and get immediate feedback. Do that a lot. It really helps you develop. We talked about lists. You saw them. They're very simple. Dicts are the most amazing things in the world. Remember, I think we covered that pretty great. Actually, let's talk about dict implementation. If we're gonna spend time teaching you how to be a Python developer, you should know how a dict is implemented. So, how is a dict implemented? Basically, wow, internet, you're not very good at this today. So a dictionary is this magical thing. And the way dictionaries work is almost every object in Python has a hash function. I can hash a number, I can hash a string, I can hash a tuple of a string and a number, and I'll get like a very arbitrary value that is quite statistically evenly distributed. Or at least should be numbers or like a special case, but I don't know. Let's hash an empty tuple. Anyway, so you can hash all these different things, and the result should be more or less statistically evenly distributed. And that means I can now I can have a list of constant size. For example, I don't know, if I have around 6 items, I'll use a list of range of length 8 of buckets. And in each bucket, I will put numbers according to the least significant bits of their hash. And And then it's really fast to decide where to put items or to look up an item according to its key. Like this is for the key, of course, not for the value. So it becomes really fast. Actually, maybe if I add buckets, I'll find a nice diagram. Because, yeah. So you have maybe 256 buckets, and each bucket has a bunch of entries that include like the key and the value, and they also include a cache of the whole hash because you don't want to recalculate it every time you need to increase the hash size. So this is a very small data structure that has, assuming your hash is good and things are evenly distributed and not all of them stuck on the same hash, this has like big O of 1, lookup, insertion, deletion, everything is O of 1, O of n iteration, everything's really nice. The only problem is if you add too many things, you'll start to have things in like colliding on their hashes, going to the same bucket. And you don't want that. So what you do is every time your hash grows too much, like for example, every time it reaches 2/3 of the size of your buckets, you increase it like to be twice as big. You copy it to a different dictionary, like to a different bucket structure twice the size, and this takes O of n to copy all the items. So on average, insertion is O of 1 because every ON insertions you'll need to copy to do another ON operations. That's called, it's on average, but the latency might be ON. So remember that. This is how dicts work. In Python, they don't look exactly like the diagram, but pretty similar. String object, you've seen it, it's very simple. Let's talk about indexing. In Python for like lists, let's have a list. For lists and for strings, a lot of times you'll want to index them. For example, A in the 0th place, you all know this, or A in the first place. So in Python, you always have -1 giving you the last item and -2 giving you the previous to last item. This works for strings too. And you have colons for like getting sublists. So for example, from the B to the D, not including the T. So this is the first index in the substring. This is the first index not in the substring. And of course, if I don't include one of them, it will give me until the end. And if I use negatives, it will work. And I can say, just give me the last 4 things, etc. The last thing I can do, this copy is, it's not useful for strings, but it is useful for lists. This is one way to copy the list. The last thing I can do is add another column and specify like my stride. Wait, no, this has to be 5 to 0. Now I can get it in reverse order. And sorry, what I meant is I can start from item 2 and get only every second item. So this thing works for most things that are indexable in Python, and that's very nice. We talked about question mark, that's an IPython only feature. You have help and dir to do that on regular Python. So help a dot append gives me the help. Here a dot append gives me all the things all the attributes of A. Very useful for learning Python. You don't have to look up in the docs, you just dir, help the right thing, see how to call it. Format strings, really nice. A equals 5, B equals, I don't know, 6. I'm using Python 2, right? Yeah. Remember, it was in the gotchas slide. A equals 5, B equals 2. Format string works. You can write any Python code, any Python expression you want in here. That's very nice. So we have ints and floats. This is a float. You can also write it, without the 0. Floats are like 64-bit floats, I think. Not sure. This works. Like you can, you can have extremely large numbers in Python and they just work. So this gives me half, and this rounds down. So, when you want to write a binary search implementation, you need the middle pointer, the middle index, you'll use the int version, double divide. None is this special object. We've talked about it. None is a special object. It is used to signify like nothing returned, nothing here, not found, stuff like that. It's kind of like nulls in many other languages. Here is a bunch of things you should Google and familiarize yourself with. We saw tuples. One major reason to use a tuple and not a list is because tuples are hashable and lists aren't, because lists are mutable. Bytes is exactly like string, except for two differences. One is it can only like contain single byte strings, so ASCII, not full Unicode. And the second is indexing bytes objects at position X will give you a number, like the numerical value of that place and not a length 1 bytes object. Learn about all these other things, they're all very useful. So Python has significant white space, we saw that. It has all the control structures you'd expect, if else, for else. What's for else? Why would for have an else? So for else, the else runs unless for was broken, unless it was like no, I wanted to edit, sorry. So we can have, A equals 1, 2, 3, 4, and if x, so for item x, if items 2 break, and then here we can, I don't know, print item, because Python doesn't have many scopes. But else, we should print something, right? So let's print found and return. You would think this is, oh, we should probably call this f with a and f with, I don't know, 1, 3, 4, and see this works. So the first call returns prints 2 and the second says not found. This is not often useful, but quite useful when it is. You'll find that you're really missing it in other languages. You also have while else. Try except has finally, which all languages have these days. It also has else. Else means except didn't happen. This is very useful because what's wrong with this code? Try I don't know, x equals a value plus b value, y equals the author, and then you have, I don't know, plus column plus x, and then you have except index error, where key error actually. In case A doesn't have this value thing, then print problem, whatever. We had a problem, and then that's our problem. That's the program. What's the problem with this program? We wanted to catch what if A or B don't have this value thing, right? But accidentally, we also caught what if Y doesn't have this author thing. And this could have been like, you know, print library func of X. This could have been someone who is not at all us throwing this key error, and we didn't even know they sometimes throw a key error. So this is the kind of thing in Python you write in the else. Like you have one line in the try where you're trying to catch the thing, and then you have the except, and then you have the else running all the code that should happen in the normal case. And in other languages, you'll start wondering what you're supposed to do because clearly they need that. You might have noticed we use white space and we have like indentation for the block syntax. So every time you have colon at the end of the line, that starts a block, and the block ends when you stop when you first have an unindented line. You can always do this instead. And Python also has like you can do x equals 1, y equals 2. You wouldn't want to, of course. Why would you do that? But it's possible. You use semicolons for that, which means it's also legal to write this, but never write that. You can't do this. Python doesn't let you like. You also can't do try for range I x equals 4. Like I think Python allows you to do this, but it doesn't allow you to do this. That's too much. And if you need like if you need a new line for some reason, for example, x equals this very long list of things, and you would like this list to span more than one line, sure, you can do that. Actually, it just works because all kinds of parents, while they're open, you're allowed to add new lines in white space as much as you want. So if you have like x equals very long func name plus other very long func name plus third very long func name, and you would like this to span multiple lines, easy, you just add parents around it, and now you can. This wonderful thing is called a list comprehension. Of course, we need words, so words can be my name, my last name, and now we can run this. And yeah, lower didn't do much, but anyway, this is like map and filter and creating a list, like an iteration and creating a list all rolled into one. Very useful syntax, very readable. Try to use it a lot. It also exists for dicts and for sets. Okay, so we know the function definition syntax. Let's talk about a few things it supports. So you can have a function. This function can have parameters. It can have optional parameters that have a default value, and then you can, you know, I'm just doing a weird thing. So you can call f with n and sum, like I don't know, n and 6, like 3 and 6. You can call f only with 3 and it will use the default of 0. You can specify the name. I want n to equal 3. You can do all this. Python functions can accept more arguments. So return sum of n times the sum of r's. And print f of 3, 4, 5, 6. So here I'm inside f, and I have 3, and args is a tuple of 4, 5, 6. It just accepts all the rest of the arguments. Very nice. You can also accept all the rest of the keyword arguments. You can do just this. You don't need to do them both. And it will give you a dictionary of all the keyword arguments entered. And sometimes you want to say this, like I have an X and a Y, and I really want the user to specify them with their names because I'm worried my user will confuse them with each other. So you can just write an empty star, comma, and then these, and then the user has to specify them by name. Of course, they can have default values or not have default values. So that's it about that. This is really nice, actually. So I can have, you know, AB equal to 3, and it's especially useful for writing the Fibonacci function where you need to replace 2 variables. What happens here is we have destructuring, like it would work with a list 2. This is just the syntax for a tuple. B comma A plus B is the same as writing this, which is a literal tuple. And then when you write something, comma, something, comma, something here, it will like iterate over this, make sure there's the right amount of values and assign them in order. You can have A comma B comma rest, and then have, you know, 3 other things going to rest. There's all kinds of fun things you can do with this. Basic pattern matching. It's very nice. Okay. So this is the syntax for classes. Here is a sorted list. Init is the constructor. Every method accepts this first parameter self. Self is like the, you know, Java this, but it's explicit, as you can see. We could name it a different name, and then we'd use a different name here. There's no, like, Python really exposes the concept of self to you. So just a moment. Okay. So that's one thing to say about classes. It's all very simple, as you can see. It all works very well. When I start a class, Python starts a new scope, and I can just write code in that new scope. I could write any sort of code I want in this scope. For example, I could have, like, you know, x equals 3. I could print x. I could do whatever I want in this scope. And let's see what happens when we load it. We start loading it. This is rude. The Python visualizer doesn't do this, but what Python visualizer should have done is gone to line 4, execute this function definition line, hopped to line 9, executed this function definition line, hopped to line 12, executed this x equals 3 thing, hopped to 13, printed this x, which, by the way, was printed. And then when we reach the end of the scope, Python takes the contents, so like all the local variables of the scope, does some magic to them, and creates a class object to contain them. When I say does some magic, what I mean is, what? Did I only get half? Oh, yeah. What I mean by some magic is look at sorted list.insert. This is a function. Okay, so no magic. Sorry, the magic happens in initialization, actually. Because s.insert, sorry, not what I meant. I wanted s.insert is not a function, it's a bound method. It's a different object that has an implicit reference to self, and when you call it, it will specify. Actually, it's just like, you know, lambda args quargs s dot insert self args quargs. This is exactly what this bound method object means. Yeah. So let's see this in action. I don't know. We have a sorted, it does the initialization. Then the next line. Oh, yeah, for each of them we insert. So we just use self dot something to call things. All very simple. Self dot something equals something sets attributes on the object. Anybody could do this. They're public. It's very easy, etc., etc. Like, you know, I could also do the same from outside. And that's it. Like, classes are and object-oriented programming is this very transparent thing in Python. You understand, like, you're just exposed to the internals all the time. Very little magic. So we have inheritance. Looks kind of like this. It's very simple. I want you to Google all of these things. They're useful. Underscore protected is like the way to write a method or a field that's supposed to be private. It's more of a convention, like we know that's what it means because that's the agreement. It's a gentleman's agreement. You can access your object's protected fields, especially good for debugging. Self.__ private will do some name mangling. It will add like the name of the class. So like a method belonging to a subclass will have a different private from a method belonging to the superclass with the same name, if they access it with the same name. Here is some other things to Google. Please Google them. Here is some other things to Google. Please Google them. Here is some other things to Google, but since they're cool, let's look at them ourselves. So generators look exactly like functions, except they have this yield thing, but in practice, they're a very different thing. Okay, let's edit this code a bit and call this like G. It will be my Fibonacci, and then we can see what this G thing is. And the answer is this G thing is a generator, and we can iterate over it, and it will just keep giving us values by executing code from here. Some of you may be familiar with this concept as a coroutine. And super nice, super useful, good to know about. Great way to have many execution routines running in parallel, actually in series. So range is how, like, Python just gives you 4 iterates over any iterable thing, any collection. And range is just a generator of the numbers between A and B with stride C. Enumerate is a way to say, I want to, here's another iterable thing, and I want to iterate over it and indexes. Zip is a way to iterate over like elements from two iterable things. So like giving the first element of these two lists, then the second of these two lists, then the third. Actually, what I should have probably shown you is for A being in zip, I don't know, range 10 and range between 50 and 70. Is you can use the same syntax as the A comma B equals B comma A in order to like get different names for the items of a pair. And zip will stop when the shortest one stops. Magic methods. So all of these dunder methods from before, remember them? I think we saw a few. Let's look at, for example, A could be 5. So A dot dunder. Oh, we have all of these dunders. We have dunder add. What happens if we dunder add to 6? We'll get 11. And we have dunder hash, which is what is actually called when I run hash of something. It just calls dunder hash. These are called protocols. Python has, they're like hooks for extending Python's functionality or making your own objects behave as if they were something else. For example, let's write a class. And this class will have a dunder call method. Hi from actually just self. And this really wants to be a format string. And now we can call it. So let's make an object C of class C, and let's call this object. And calling this object just calls the call thing. Of course, regular, functions like hash, they just have a call dunder method. And that's how everything works. We have new for making these, like for construction. We have, I think it's called 0 or empty or something like that. I don't know. Anyway, a way to say whether we are truthy or falsy. By the way, in Python, the falsy things are empty list, empty tuple, empty string. Basically, everything that can be iterated is expected to have like to implement the protocol for emptiness. Let's find the name of this protocol. Not empty, 0. How is it called? I don't know. I'm not finding it here. Should have been called bool, but it isn't. Anyway, you're supposed to implement the emptiness protocols for all your containers and have them be false if they're empty. So the number 0 is false in Python, and of course, false is false. Everything else is probably true. So you can use like if some things to check for emptiness. Yeah, tons of things are hookable and extensible in Python. Look into all of these cute protocols and also some other things like Google all of these things are important and interesting. And type annotations in docstrings. So you can have type annotations in Python. Python, myty, let's look at the type annotation. Why are you so, what? Seriously? A type annotation in Python. As I say, there's outside tooling that can use this type annotation to raise errors like when you have wrong types for things or you're using them wrong. Doc strings. So in Python, when I write a method, for example, actually everywhere I can use this syntax to define long strings. So s equals this, and hi, my name is spelled Aur. Specifically, when these strings are the first thing in a function, they will be assigned to that function's doc, a doc, and Python will treat this as a documentation. So when I call help on A, I will get built-in mutable sequence. These are called doc strings. They're Python's documentation convention. I'm pretty sure we're almost over and we're more or less on time. Actually, we're a few minutes out of time. Google this, and we already got here, so that's all. If you're in a hurry, this is the time to go home. For all of you not in a hurry, any questions? Oh my God, only half people left. So anybody learn anything new?
A lot, actually.
I learned a bunch.
I'm glad to hear. Again, treat this as a talk saying more or less what you should Google. Don't consider yourself knowing Python now, but like, of course, I'm going to share the slides and you can use them as a table of contents for interesting things to know about Python, and just keep Googling these things until you know Python. Of course, build projects. Building projects is how you really actually learn things. Any other questions, feedback?
Yes, so I actually have a question.
Yes.
I heard that Python have like built-in debugger like traceback or something
Yeah,
like
that
that.
was actually, it's called PDB. It's one of the last slides we've seen. Google it. It's very nice. Really like it for simple debugging. Like it's command line and you guys are gonna hate it. But like when I have a Python program not working for me, I can just minus mpdb this file. I don't know. Let's find a file here. I can see what I'm doing. House maybe xml.py. And now I'm in the debugger, and I can, you know, that's all. This is a very short file. Let's choose another file. Views. So this is a bit longer, and it's going to fail pretty fast. So let's run it until it fails. And I see it failed on import collections. So now I can check where I am and which variables are defined. And it's very useful for like my code fails at some point and I don't understand why. So I like hop into the debugger and like evaluate all the different variables and exploring. Like it printed a list of things, but I want to look at the fields of the things it printed. So I just hop into the debugger and do that quickly. Very useful. Also, I can write wherever I want in my code, import import pdb.setTrace, and it will launch the debugger. Actually, I think these days there's this syntax for it, which is pretty new, and it does the same. Very nice. Other questions?
Cool, thank you.
I have no idea who I'm talking to because you don't have video on, and for some reason it's not showing me people without video on. Right, more questions? Then I'll stop the recording and let's go home. Goodbye, everyone.
Bye-bye. Thank you.
Thank you very much.
Bye.
Goodbye.
Bye. Thank you very much. Very knowledgeable, very informative.